Here we're looking at the function f of x equals x plus 1 over x on the closed interval 1 to 3, and we're asked to show that the mean value theorem applies and find the point guaranteed by the mean value theorem. So let's start by reviewing what the mean value theorem says. Okay, it tells us that f needs to be continuous on the closed interval and differentiable on the open interval. That's the if part of the theorem. If we can show those things, then we're guaranteed the then part of the theorem. So let's see. Well, f of x equals x plus 1 over x is a rational function, and rational functions are continuous on their domains. The only place where this rational function gives us a problem is at 0 here, so we'll say x not equal to 0, but we're only looking at the interval from 1 to 3. So this tells us that the function is continuous. That's half of what we have to show. Differentiable, so there's the continuous part. For differentiable, there's no corners. The only place, since this is continuous, the only place where this would not be differentiable is on a corner or an asymptote. But on that interval 1 to 3, there's no asymptotes, and this is a rational function, so there's no corners. So we can say that's also differentiable. On these kinds of exercises, make sure you address that the function is continuous and differentiable. If you just jump straight to showing that a point exists and finding the point, you haven't justified using the mean value theorem. So it's actually an important point of the exercise is to address that it's continuous and differentiable. You don't have to go into a ton of detail, but if you don't say anything about it being continuous, it's technically incorrect. So I'll just say no corners or asymptotes. Check. How about no asymptotes, at least on the interval on 1 to 3? Add that in just to be clear. Okay, so back down to our theorem, we have shown that it's continuous on the closed interval and differentiable on the open interval. Very rarely are you going to really split hairs on these end points, maybe on some of the really advanced exercises, but really we're just looking at the stuff essentially between 1 and 3. Okay, so now we get what the theorem gives us. Then there exists at least one point C in AB such that that derivative equals the average slope, or the slope of the secant line. So let's figure out what this quantity is here, f of b minus f of a over b minus a. So we'll say the m, how about m subsecant? There we go, a way of denoting that. Okay, is f of 3 minus f of 1 all over 3 minus 1. All right, so now we just do a little bit of algebra and simplification here. F of 3, 3 plus 1/3 minus f of 1, so parentheses 1 plus 1 it looks like, all over 2. Okay, so let's see here. This is going to be 2 here, so 3 minus 2, that's 1 plus 1/3 all over 2. Get a common denominator here. How about 3 over 3? That gives us 4/3 over 2, which comes to 2/3. Remember, when you have a fraction on the top here, it just bumps down a layer. So that would be 4 over 3 times 2, which simplifies to 2/3. So there's that. So back to our proof here. So we can say now, thus, the mean value theorem guarantees, we can say that, some point, some C in the interval, well, the open interval 1 to 3, such that, I'm just going to abbreviate that as such that, let's see, what happens at that C? Well, f prime of C equals 2/3. And that's the end of the theorem, so I will put my little proof box there. I'll even fill it in. Right, so we're guaranteed some point in that interval that has the derivative of 2/3 at that point. Note that the mean value theorem does not give us a way of solving for it. In this example, it turns out that we can solve for it, but the mean value theorem has nothing to do with that. And if you wanted to use the fancy mathematical notation here for this conclusion to the mean value theorem, you could say there exists a C in 1 to 3 such that, and then f prime of C equals 2/3, right? It's a little bit more compact and I think much cooler looking notation. Okay, well, let's find the point, right? The exercise asks us to find the point, so we leave the mean value theorem behind and let's just see if we can find the point. Okay, recall that our function was f of x equals x plus 1 over x. And we need to find some point on the derivative such that the derivative equals 2/3. Okay, well, let's find that derivative. Derivative of x plus 1 over x is 1 minus x to the minus 2. So let's see, we can subtract 1 from both sides. That gives us negative 1/3 equals negative. Let's write this as 1 over x squared. And how about now, I'll just cross multiply up. I'll also get rid of those negatives since there's a negative on each side. All right, so x squared equals 3. And then we can take the square root of both sides. X equals, don't forget the plus or minus, rad 3. But it turns out we don't really need that plus or minus. Let's see, rad 3, if we put that in the calculator, we get about 1.73. 1.73. So note that the positive version of rad 3 is in our interval. Remember, let's see, I've lost the interval here on. This was 1 to 3. 1 to 3. Okay, so that's important. So positive rad 3 is inside our interval, but negative rad 3 is not. So we're going to ditch the negative case and just focus on the positive rad 3.